Hi, I'm Andrew Armstrong and welcome to the Back Office Show. We're working with this Optimate. I'm trying to hook into its power, again unsuccessfully on the last video, but I'm keeping persistent in it. I don't want to bin it just yet. So this is the regulator that's on there. It's got a V out and a V in. We've got a 12 volt supply, but we don't really know what it's V outing. It might be 12, it might be a bit more, a bit less, who knows. So I'm going to try tacking it straight onto the V in on this, and we're going to see if that works, and if not, we're going to just keep at it. Probably we can probably just do it on the V out. So we've got V in here, which is the pin on the right here, this rightmost pin of this sort of dastardly trio. Pop that right there, and yeah, that's really quite nasty bit of soldering there. Let's touch this up. Let's try to at least make it somewhat presentable, and that will do nicely. Thank you very much. So we then have to work out though which we think is probably the negative side of that circuit. Well, we've got a big, I was going to say a big electrolytic there, but that doesn't seem to want to do anything with it. Let's try elsewhere. Very briefly we saw a light flash there as we probably blew up something. Yeah, there we go. That's a reverse polarity light there. That's not a good indicator. Let's do a sanity check and check the polarity of our system here. We've got our positive. We should be reading -12 because I've got the probes the wrong way around. If we don't reading -12, there's a problem. Oh, that's good. That's nice. That's real good. So we're putting that on the V in, but we need to, again, let's say we have to kind of ground this, so we have to find the reference for the negative. It has to be something like that. A big old snap though came off there. That one? Or that one? No. I wouldn't advise you test it, by the way, just by sort of randomly applying. Just so weird. It's weird. So just looking at this, if you know it's got a bridge rectifier in it, there's these 4 diodes that are dotted in there, and basically you know that one side of that rectifier bridge is going to be the positive and the other is going to be the negative. So it's tricky to try to figure that out though, which is which this way. So I'm going to try to get in there and basically probe each end, and one end will beep, which is good. Is what we want. Shows continuity. Are we not even getting that? How is this circuit made? I've given it a bit more of a go. I wanted to really make sure I'd exhausted this before just chucking it, because frankly it's a lot of effort. But really it does require, it seems, an AC waveform. That's basically what I can determine. If I put a DC one way, I see one set of lights flash, and then I put the DC the other, I see another set of lights. So it's almost like 2 bits of logic are sort of relying on that. And without buzzing out the circuitry, I can't be totally sure, I have to admit. But it is a bit insano, because when you work your way through, it definitely has a big regulated step, so it is rectified and regulated. There's rectification going on here and then regulation, but I think, and I might be losing my mind on this, that it's probably using the other half of the waveform. I just don't know. It's using some of it elsewhere. So I suspect it's got something going on for the logic that's quite different than what's going on for the actual charging circuitry. So it might be using some of the effects of the AC itself, but without really sitting down and working my way through this board, I can't be sure. So maybe if you know, great. Maybe I'm totally wrong. Maybe I'm on the money. Let me know. I certainly can't tell you, but it's very, very odd indeed.